Hello class, today we're going to be taking a look at a little bit tricky topic of dividing fractions and how we can represent that in our written work as well as our models. So because this is a tricky topic, let's make sure that we start with what we already know, which is how to do basic division. So, of course we all know that 12 divided by 2 is going to be equal to 6. So let's talk about, well, what does that mean to help us figure out how this works with fractions. So the first number in a division statement is called the dividend, and it's the amount of objects that you start with. So in this case, our 12 there tells us to start with 12 whole objects. Obviously, I've got 12 full circles here in my drawing so far. Divide means to split up, so we're going to be splitting or cutting up this single group of red objects into some different things. Now the question is, what do we divide it up into? Well, our second number in our division statement is called our divisor, and there are different ways of thinking about the divisor, but one way is to think of it as the number of equal groups we're going to split up our 12 objects into. So that's the first way I'm going to do it. I'm going to look at that divisor of 2, and I'm going to say, okay, it's telling me to split up my 12 objects into 2 equal groups. So I've obviously got my 2 groups ready to go here, first group and second group. And of course, if these were physical objects, we could kind of sort them one by one. One into group, the first group, second group, 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 first group, second group. I did end up having an equal number in each group, and I could sort them and they would look a little bit like this. So what is that 6 then in our division statement? Well, the 6 is the quotient, the answer to a division statement, and it's telling us that if we take 12 objects and we split them up into 2 equal groups, there will be 6 of those objects in each group. And of course, if you count them, there are in fact 6 of those objects in each group. We still have 12 objects in total. It's just instead of them being together in one group, we've split them up into 2 equal groups, and that's because we were dividing by 2. And why were we looking at that? Well, we can actually use most of those same ideas to divide fractions by whole numbers. Remember that for a fraction, the numerator, the top, is going to tell you how many parts you actually have at the start, and the denominator tells you how many parts make one whole. So the denominator basically tells you just what the shape the parts are. And one little trick that we'll use later on today is that we may need to make an equivalent fraction that has more smaller parts so that they can be split into our desired number of groups, but we'll get to that point in a little bit. So let's take a look at this fraction division statement. We've got the fraction 4/5 divided by 2. So how could we interpret that? Well, the first thing I want to look at there is our denominator of our fraction, 5 or fifths. All that's telling us is that one whole object, so if a circle is a whole, is going to be divided into 5 equal parts. 1, 2, 3, 4, 5 equal parts. And so all that 5 is really telling us is that each of our parts is shaped like this. This particular pie section would fit into any one of these places. So that's all the 5 is telling us, is that our parts are shaped as fifths. This is the type of object that we have. The 4, of course, tells us that we actually have 4 of those sections. So, of course, I've shaded in 4 out of the 5 sections of my circle. So what do I need to do? Well, I need to divide those up into 2 equal groups. So to help me kind of visualize that, I've taken my same 4 sections and I've just kind of drawn them separately here. Each of these sections is 1/5. There's 4 of them, so this together all represents 4/5 still. So this 4/5 here is what's represented by all of this together. And I want to divide those into 2 equal groups. Most of us can probably see that, hey, here's a group of 2 and a second group. Those are equal groups there. And so I could say that, well, 4/5 divided into 2 equal groups is going to equal what? Well, if I look inside of each of my groups, I've got 1/5, and then I've actually got a second fifth. So my answer is going to be that inside each group, I'm going to have 2/5 in each group. And so if we look at that, we've got 4/5 divided by 2 is equal to 2/5. We can sort the pieces that we have. We have 4 of them. And we can split them up into two equal groups. That's going to cause there to be, two of those parts in each of those groups. And so we can say that our answer is 2/5. Now what I want you to notice is that dividing by 2 is the same as finding half of our starting value. You know, obviously if we were to take our initial picture here, cut it in half, each of those halves would have 2/5, right? We've got 2 sections here out of 5 total, 2 sections here out of 5 total. And so this is actually a really useful fact for us, because saying that dividing by 2 is the same as half of means multiply, and half is this fraction. And so we can see a kind of relationship here. Our first fraction is going to stay the same when we're doing this work, but what we can do is we can change the divide sign to a multiplication sign, as long as we change our second fraction into what's called its reciprocal, flipping the top and the bottom number. So I've used our little trick here that a whole number can be written as itself over 1, 2 out of 1 whole, and I've then flipped it to make it 1/2. And this actually works out for any fraction division, and so this is kind of our key rule for symbolically completing any fraction division. The math rule for this is multiply by the reciprocal. We're first going to use our trick to rewrite any whole numbers as fractions over 1. But then the meat and potatoes of the rule is that we're going to leave the first fraction alone. So notice 4/5 isn't changing there. We're going to change the division sign in the middle to a multiplication sign. That's the multiply part of multiply by the reciprocal. And we're going to flip the second fraction. Flipping a fraction makes it into its reciprocal. Reciprocal is just a fancy word for a fraction that has been flipped. And after we've done that, we can complete our normal multiplication steps, multiplying the top by top, bottom by bottom, and simplifying. So let's go ahead and take a look at another problem, something a little bit like this, with 3/5 divided by 2. Oops, I think I'm getting ahead of myself. So let's go ahead and take a look at that. Where I want to come back to the point that we made earlier, which is that we may need to make an equivalent fraction with more smaller parts that can be split into our desired number of groups. So our problem here is that we have 3/5. I'm just going to roughly draw fifths here. And that's a really rough drawing. 3 of them. And I want to split those into 2 groups. But I can't do that evenly, right? I could go first group, second group. But then I'm not going to have a right number in each group, right? I would have like 2 in one and 1 in the other. So that's not an even or equal group. So that so far is not going to work in the same way. But we again have that little trick that we can make an equivalent fraction with more smaller parts. So I can say that the fraction 3/5 is equivalent or the same as the fraction 6/10. And how do I do that? Well, I just split every part of my 3/5 in half, and that really makes twice as many parts. So of course, to make an equivalent fraction, you're going to multiply top and bottom by the same number. And of course, that gives us our equivalent fraction 6/10. This 6/10, you'll notice, is the same amount of area shaded as our original 3/5. It's just kind of split up in a different way. And why would we do this? Well, it helps us go ahead and split these up into 2 equal groups. So let's go ahead and think we'd have 1 in group 1, 1 in group 2, 1 in group 1, 1 in group 2, 1 in group 1, 1 in group 2. How many are going to be in each group? Well, there's going to be 3 sections in each group. All right, 3 of them for group 1 and 3 of them for group 2. Now what we do need to be careful of is that these are not fifths, these are tenths. So our answer here would actually be 3/10, not 3/5. So we could say that 3/5 divided by 2 is going to give us 3/10. And again, this matches with our earlier rule, which was to multiply by the reciprocal. Remembering 2 is 2 over 1. So we're going to change our division sign to multiplication, and we're going to flip the second fraction. The 1 was on the bottom, now it's on the top. The 2 was on the top, now it's on the bottom. 3 times 1 on the top is 3, and 5 times 2 on the bottom is 10. So obviously we get that same answer either way. Now, I've been using the circle drawings for fractions here just because I think for most people they're a little bit easier to interpret. But as far as if you were doing this on your paper, your rectangular holes are going to be a lot easier to draw, especially if we're getting up into higher denominators. So let's just take a think about how we would draw this maybe on a test. We're going to start by drawing our 3/5. So I need to divide up my hole into 5 sections, equal-ish. I'm going to shade in 3 of those. So there's my 3/5. And what I can do is I can split these into 2 equal groups. First group on top, second group on the bottom. And I could go ahead and I could say, well, how many objects do I actually have in a single group? I have 3 cells in one group. And how many are in the one hole? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the hole. So of course this is also going to give us the answer 3 out of 10 for our division statement. Okay, so that would be how you might want to draw that a little bit easier on a test as compared to using the circles. Now, what remains is how can we model other types of fraction division? We're going to be able to use that multiply by the reciprocal rule for any symbolic work. The question is, how can we model other types of fraction division? And our problem is that if the divisor, the second number in a division statement, is not a whole number, you can't treat it as the number of equal groups. For example, how do you have less than one full group? Kind of impossible. So there's a second way to interpret the divisor, and that is to treat it as the number of objects in a single group. So if we go back to our 12 divided by 2 equals 6, the other way of thinking of that is that the 2 tells us that we're going to make groups with 2 objects in each group. Basically, every pair of objects will make up one group. So if we do that, we could say, here's a pair of objects, that's one group. Here's another pair of objects, that's 2 groups. Third pair, fourth pair, fifth pair, sixth pair. And so, of course, our quotient in this case is going to tell us that we have made 6 groups. So that's the second way of interpreting a divisor, and this is important for when we are dividing by a fraction. The divisor is a fraction itself. So let's start out by taking a look at a whole number divided by a fraction. So something like 2 divided by 3/5. I'm going to start by thinking about my 2. I do know that my 2 is 2 out of 1, and that means to start with 2 whole objects. First number, dividend, always the amount that you're starting with. Now what I need to do here is I need to split up, now it's my divide sign, these into groups of 3/5. Remember, the bottom number is only going to tell us the shape of my objects, not how many of them they are. I want the number in my groups to be 3 of those objects. Now I don't have fifths here, I have wholes. So what I'm going to do is I'm going to make that equivalent fraction for 2 over 1 that is made out of fifths. And of course I can do that by multiplying the top and bottom of 2 over 1 by 5, and that will make an equivalent fraction 10/5. So obviously I still got my 2 circles here, it's just instead of having them as whole circles, I split them up into 5 parts each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 of them in total. So now that I have my 10/5, I'm going to need to go ahead and split them up into groups of 3. And I'm writing out the word fifth instead of the 5 on the bottom to remind you that the 5 on the bottom is just telling us the shape of these parts. They're fifths. So what I've done here is I've kind of broken up my circles and I've drawn out the 10/5 that I have in those circles. You know, obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 I've drawn. So I still have the same number of fifths here. And I want to make groups of 3 of those at a time. So here's a group of 3. Obviously here's a second group of 3. Here's a third group of 3. And our problem obviously is this guy here. What do we do with him? Well, he's a remainder. He's not enough to make an entire 4th group. So I can say that I'd have 3 whole groups from this part. And how much is left over? Well, I have one section, obviously. But that's 1 out of what? Is it 1 out of 5 or 1 out of 3? Well, remember, we're trying to make groups of 3/5 at a time. And fifths, this tells us the shape. So what we have is 1 out of the 3 that we would need for another group. And so we could say altogether as a mixed number, we have 3 1/3 groups. And therefore we could conclude that our original division statement, which was 2 divided by 3/5, is equal to 3 1/3. 3 1/3 is, 10/3, obviously. Yeah, 3 times 3 is 9, plus 1 is 10. Now, let's just double check that with our symbolic rules. We're going to write our 2 as 2 out of 1. We're going to change our division sign in the middle to multiply. We're going to flip the second fraction. 2 times 5 on the top is 10. 1 times 3 on the bottom is 3. Ta-da! Same answer in all those different ways. Now, again, as far as drawing this on your paper, your rectangular holes are usually going to be easier to work with. So here's 2 holes split into 5 sections each. We need to arrange those into sections or into groups of 3/5. So we could go ahead and say this guy here, rearranged over here, this one over here, this one over here. That's one group of 3/5. You could also circle them. That's a group of 3/5 right there. Same thing down here. These guys can make a second full group of 3/5. And we can make a kind of L-shaped group of 3/5 to fill in another guy. Used up all of those. And then we've got one left over right here. So we have 3 full groups and 1 out of 3 in the last group. All right, trickiest thing to do is having a whole number divided by a fraction. That should be fraction divided by fraction. And we got something like this, 3/4 divided by into groups of 2/3. And our issue here is that we're not talking about the same size pieces. These are quarters, and these are thirds. So what I want to do here is I want to make this a little bit easier to understand. So I'm going to make these actually have common denominators so that we are talking about the same size pieces. Obviously the denominator that is common between 4 and 3 is 12. So let's make that common denominator. We'll have 9/12 for our first fraction divided by 8/12 as our second fraction. And this is much easier to understand. We have 9/12 at the start. We want to divide it or split it up into groups of 8/12. Is that a V in there? I don't know. 12ths. I don't think there is. Probably wrong now that I've done that. That's okay. So we're going to go ahead and draw out a 9/12 section. We need 12 equal parts in this. There you go, there's 12 equal parts in that whole. I have 9 of them. 2, 3, 4, 5, 6, 7, 8. 9 of those sections exist, and I want to split those up into groups of 8 twelfths at a time. So here's another whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. I actually need a spare one. Look how perfect these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. And so I'm going to go ahead and reorganize those into groups of 8 twelfths at a time. So that's my cutoff right there. Oops. Right there. That's better. So I could rearrange these and I go, okay, this guy goes here, 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 so on and so forth. That's one group of 8 twelfths. And of course I got one left over in my next group, so I've got 1 out of 8 of that group. So of course together I could say that this division is going to equal 1 and 1/8 groups. And if I convert that to a improper fraction, that's going to be 9/8. Now, again, can I confirm that using my symbolic rules? Let's go ahead and do that. So we got 3/4. Instead of divide, we're going to go multiply. Instead of the second fraction, we're going to flip it. And we're going to multiply 3 times 3 on the top is 9. 4 times 2 on the bottom is 8. Ta-da! There's your 9/8. Okay. So this is definitely a tricky topic with dividing. The rule for doing the symbolic work is really easy. Multiply by the reciprocal. Representing them with the models is a little bit trickier to wrap your head around. But again, remember the idea of, are you divided into a number of equal groups, or are you divided into groups of a type of object? And that can help you with figuring those out.